Hello guys, today we are going to do grade 12 question paper and we are only going to focus on momentum, which is question number 4. As you can see that it is 11 marks, so it means we are only going to take 11 minutes. So the first thing that we are going to do, guys, we are going to read the statement before going to the questions, because that's where most of the information is, even if we are given the diagram. So let's get to it. It says a wooden trolley of mass 2.7 kg moves to the left with a constant velocity of 3 meters per second. A bullet of mass 0.03 kg is fired horizontally from the left towards the trolley. See diagram. So we have a scenario here. We have a bullet here which is going to the right with a mass of, you can say mass of a bullet is equals to 0.03 kg, and then we have a trolley that's traveling to the left with a initial velocity of 3 meters per second with a mass of a trolley is equals to 2.7 kg. So what else do we have here, guys? Alright, so let's continue. And the bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. The average net force exerted by the trolley on the bullet during this time is 591 Newton. The bullet trolley combination now moves to the right. So this is before collision, and then after collision we have a bullet trolley system or combination. So it's like this, where they both move to the right, so it means the final velocity is the same. That's what we must know already. So we have to choose our signs. To the right we can say it is positive, to the left it is negative. So we were told that the bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds, and the average net force exerted by the trolley on the bullet during this time is 591. The net force is 591 exerted by the trolley on the bullet. So let's now go to our questions. It says ignore all frictional and rotational effects. 4.1, it says write down the magnitude and direction of the average net force that the bullets exert on the trolley. So by Newton third law, I'm not going to explain it, guys. So the bullet exerts the same force as the trolley, but then in an opposite direction. F net is equals to 591 Newton to the right or east, meaning that way, guys, because the bullet was going that direction. Let's move to the next question. It is 4.2. It says calculate the magnitude of the velocity with which the bullet strikes the trolley. So we can write our formula down. Momentum before initial momentum is equals to sum of momentum after, or before momentum before, sum of momentum before is equal to sum of momentum after. So what do we have? Momentum before, we have the mass of the trolley, the mass of the bullet times its velocity, initial velocity, plus the mass of the trolley times its initial velocity, which is equals to the bullet trolley combination velocity, the bullet trolley, it is combined. So we are going to add the mass of the bullet and the mass of the trolley. So as you can see here, guys, we have two unknowns. We have this velocity final and velocity initial. This one we have, so we have to have two equations at least. So let's now try to look for this. So we know, guys, we are given that okay, before that we can use for when we consider Newton's second law in terms of momentum, the formula, it is F net is equals to the change in momentum over the change in time during contact time. So we can either use for the bullet or for the trolley, but then if we use for the bullet, we are going to have two unknowns here. We are going to have the mass of the bullet, Vf minus Vi. So Vf and Vi of the bullet are unknown, so we can only use for the trolley in this case. So our F net, we can substitute, it is 591 is equals to the mass of the trolley. Okay, let's not substitute first. Its F net is equals to n, the mass of the trolley, Vf minus Vi, all over change in time. So F net is 591. We substitute now. The mass of the trolley is 2.7. The final velocity, we don't have the initial velocity. It is to the left, which is -3 meters per second of the trolley, -3 all over 0.02. That's our time. We multiply this side, 5.91 times 0.02, which is equals to 2.7 Vf. Negative times negative, it becomes positive 3, and then we can divide all by 2.7, then 2.7 cancels 2.7, and then here let's see what we get. We have 591 times 0.02 over 2.7, so we get 4.378, which is equals to Vf plus 3. So we take 3 to the left hand side. V 4.378 minus 3 is equals to Vf. So our Vf is equals to minus 3, 1.38 meters per second. So we have our final velocity that we can substitute here and get Vi. So we rewrite our equation here, mb VIB plus m trolley Vi trolley, which is equals to Vf of both the trolley and the bullet, m bullet plus m trolley. So let's see, we have 0.03 final velocity, initial velocity of the bullet, that's what we are looking for, and the mass of the trolley is equals to 2.7. The initial velocity is -3, which is equals to the final velocity for both is 1.38, and the combination of the mass is 0.03 plus 2.7. So let's see guys, we have 0.03 VIB. So I'm going to take this to the other side. So let's calculate it here first. It's 2.7 times -3, it's -8.1 this side. So when it goes that side, it becomes positive 8.1 plus this 2, 1.38 times 0.03 plus 2.7, so it becomes 3.7674. so let's add this 2 plus 8.1, it becomes 11.8674. on this side we still have 0.03 VIB. So VIB is equals to, we divide both sides by 0.03, 11.8674 divided by 0.03, we get 395.58 meters per second. So that's our initial velocity of the bullet. It means it is to the right. So let's move to 4.3. It says state the principle of conservation of linear momentum inwards. So what does it say? It says the total linear momentum in an isolated or closed system remains constant or concept. So you can either use the total linear momentum is the total linear momentum in an isolated system remains constant, or the total linear momentum is the total linear momentum in a closed system remains constant. So whichever is going to be easier for you guys. So we have 4.4 here. It says calculate the magnitude of the velocity of the bullet trolley combination after the collision. So we have already calculated that because we had no choice, but then we can recalculate it since we used the formula of F net is equals to changing P over changing T. So now we can use sum of momentum before is equals to sum of momentum after. So any formula that we can use there, so it's going to be M of a bullet VI plus M of a trolley VI, which is equals to the VF, that's what we are looking for, and then M of a bullet plus M of a trolley. So M of a bullet, we know it is 0,03, and then we found VI to be 395,58 plus the mass of the trolley is 2.7 and the velocity is -3, which is equals to final velocity. The mass of the bullet is 0,03 plus the mass of the trolley is 2.7. So we can add all the values on the left hand side. It is 0,03 times 395,58 plus 2.7 multiplied by -3. So it is this side, it is 3,7674, which is equals to the VF multiplied by 0,03 plus 2.7, 2,73. So we can divide both sides by 2.73. So what do we have? It's 3,7674 divided by 2.73. So VF is equals to 1.38 meters per second. So that's what we get, guys. So thank you for watching.